Opening scene. Calm electronic music plays as the camera pans over glowing silicon wafers, robotic arms assembling chips, and then slowly zooms in on a map of India, pulsing with light around Bengaluru, Hyderabad, and Gujarat. Welcome back to Beyond Binary, where we decode technology, geopolitics, and the future. Today, we're diving deep into one of the most important and least understood stories of our time: India's rise in the semiconductor world. The title says it all. Semiconductor empire, India's design strong, manufacturing weak. Let's unpack that. Every smartphone, car, laptop, and even your washing machine runs on one thing: semiconductors. These tiny chips are the lifeblood of modern civilization. They're what electricity was to the 20th century, what steam was to the 18th, and what AI is to our future. And the country that dominates semiconductors doesn't just lead the tech world, it controls the world's digital nervous system. For decades, that power has been concentrated in a few hands: Taiwan's TSMC, South Korea's Samsung, and the United States' Intel and Nvidia. But as the world learned during the great semiconductor shutdown of the early 2020s, that concentration came with enormous risk. Let's go back to that for a moment. The semiconductor shutdown, sometimes called the chip shortage crisis, wasn't a single event. It was a global chain reaction. It began quietly in 2020, when the pandemic froze manufacturing lines in Taiwan and China. Logistics collapsed, and suddenly automakers, smartphone giants, and even defense contractors couldn't get the chips they needed. What started as a supply delay turned into an industrial meltdown. By 2021, assembly lines were shutting down worldwide. Car companies like Ford and Toyota had unsold cars sitting in factories because each was missing a $5 microcontroller. The global electronics industry lost over $500 billion in value that year alone. And the biggest shock? Almost all the world's cutting-edge chips came from a single company, TSMC, based in Taiwan, a region already under geopolitical tension. That crisis taught the world an unforgettable lesson. Chip dependency isn't just economic, it's existential. Every nation began racing to secure its semiconductor future. The US launched the CHIPS Act, Europe built its own CHIPS initiative, and India, finally, stepped onto the field. But here's where India's story takes a fascinating twist. India isn't new to the semiconductor ecosystem, it's just been invisible in the manufacturing part. For years, India has been a design powerhouse. Over 20% of the world's chip design engineers work from India. Giants like Intel, Qualcomm, AMD, and Nvidia have massive design centers in Bengaluru, Hyderabad, and Noida. In fact, if you're using a chip inside your phone or laptop right now, there's a good chance part of it was designed by an Indian engineer. Design, however, is only one side of the chip story. The other, and much harder side, is fabrication, the process of actually making those chips. That's where India has lagged behind. To understand why, let's break it down. Semiconductor fabrication, or fab as it's known, is one of the most complex industrial processes ever developed. It requires ultra-pure materials, nanometer-level precision, clean rooms more sterile than operating theaters, and supply chains that stretch across continents. Building one high-end fab plant can cost $10 to $20 billion, and it needs a constant, stable supply of water, electricity, and skilled technicians. Now here's India's paradox. The country has unmatched talent, thriving design ecosystems, and political will, but it's been historically weak in infrastructure reliability, supply chain maturity, and policy execution. When the global chip shortage hit, India's government saw an opportunity. In 2021, the Semicon India initiative was launched, an ambitious $10 billion incentive program to bring chip manufacturing to Indian soil. Partnerships began forming: Vedanta with Foxconn, Micron with the Gujarat government, ISMC with Next Orbit Ventures, and Tower Semiconductor. The excitement was electric. India wanted to become not just a design hub, but a full-stack semiconductor power. But by 2023, reality hit hard. The Vedanta-Foxconn project, initially touted as India's semiconductor breakthrough, collapsed. Disagreements over technology partners, funding, and execution timelines brought it to a halt. The project was supposed to bring India's first major fab to Gujarat, but it turned into a cautionary tale. Then came the Semiconductor Shutdown 2.0, not a global crisis this time, but a domestic one. In 2024, several pilot fabs in India paused operations after power grid fluctuations and water contamination disrupted production cycles. It was a stark reminder that you can't simply will a semiconductor industry into existence. You have to build it, literally atom by atom. So what exactly causes these shutdowns? A semiconductor shutdown happens when any critical part of the chip-making process halts, be it due to raw material shortage, equipment failure, contamination, or supply chain disruption. Unlike other industries, you can't just pause and resume production. Even a brief power outage can destroy months of wafer work worth millions of dollars. That's why fabs run 24/7 under hyper-controlled conditions. A shutdown doesn't just cost time, it wipes out yield, damages equipment, and disrupts global supply chains. The effects ripple outward. Smartphones get delayed, automobiles stop rolling out, defense systems slow down, even AI training clusters grind to a halt. Because every server, sensor, and circuit ultimately depends on those chips. For India, the 2024 mini shutdown became both a wake-up call and a turning point. It exposed weaknesses in infrastructure, but also triggered reforms. The government began fast-tracking industrial water recycling projects, improving energy reliability, and training engineers in fab operations rather than just design. Companies like Micron Technology started building advanced packaging and testing facilities in Gujarat, signaling that while full fabrication might take time, India could dominate the back end of the chip value chain. So, where does India stand now in 2025? The country has established a strong design identity. Nearly 30 of the top 50 semiconductor firms have R&D centers here. New startups are emerging in chip verification, IP design, and embedded systems. On the manufacturing front, India is taking a layered approach, starting with chip testing, packaging, and specialty fabs, while preparing the ecosystem for large-scale logic chip manufacturing in the next decade. But the challenges are still steep. Competing with Taiwan or South Korea isn't just about technology, it's about building trust, resilience, and long-term consistency. Investors need assurance that power won't flicker, that water won't run out, that policies won't change mid-project. Still, India's strengths are undeniable. A young, skilled workforce, a booming electronics market, and a government that sees semiconductors as strategic, not just economic assets. The global geopolitical environment, too, favors India. As US-China tensions rise and supply chains diversify, companies are looking for stable, democratic, tech-capable partners. India fits that bill perfectly. So yes, India's design game is strong, but manufacturing is still a mountain to climb. Yet every empire starts with a spark. Japan began by assembling radios before it built microchips. South Korea started with consumer goods before mastering DRAM. Taiwan was once an outsourcing hub before it became the world's semiconductor king. India's story might just be at that inflection point. The road from blueprint to silicon is long, but every transistor begins with intent, and India has that intent in abundance. The next decade will decide whether the world's most populous democracy can turn its design empire into a manufacturing revolution. Until then, the question isn't if India can build chips, it's when and how many global systems will depend on them once it does. Because in the semiconductor world, whoever controls the chips controls the future. Beyond binary, where circuits meet civilization. Stay curious, stay informed, and if you found this breakdown useful, don't forget to like, share, and subscribe for more deep dives into the technology shaping tomorrow.